press record right now and we'll go back to separable. Okay, separable differential equations. And oops. And remember the form was x dot is equal to ft multiplied by g of x. Okay, really important is that no x's here, no t's here. Okay, really important. And it's really important to identify correctly in the start, because if you somehow include an x or a t there, you're not going to be able to solve it and you're going to mess it up. So really careful. We're going to do examples, no worries. Okay, first of all, the first way you do differential equations is you look. So the first step is look for constant solutions. Okay. What are these solutions? What are these constant solutions? It means g of x is equal to 0. Okay. Let's just say, and you find, I don't know, I'm going to give an example. You find g of 5 is equal to 0. Okay. I don't know. I'm just giving an example. This means that x, the function x for all t's, is equal to 5. Okay. Remember, you are supposed to find x. Okay. And the idea is that if you find a constant solution, a constant number such that g of x is 0, g of 5 is 0, then x, the function x for all values of t is just 5. Okay. It's just a constant function equal to 5. Okay. Now, once you do this, you go to step number 2, which is the case where g of x is not 0. Okay, g of x is not 0. The way to remember and the way to solve how to solve this is separable means separate. Okay, that's how I remember. I think it kind of makes sense. So your equation was x dot is equal to f of t g of x. Separate everything. X dot over g of x is equal to f of t. Okay. And now you can understand why, if you have identified your f and g in the wrong way, this separation process is going to look pretty scuffed. Okay. So be careful with that. And now you just integrate everything. Okay. And you're going to have integral of 1 over g of x dx. And here integral f of t dt. Okay. And now you just solve this and you're done. Okay. Now solve this and done. Okay. I know there probably, if you look in Niels's old notes or something like that, he just says, hey, I don't know, Neil, okay, I'll say Niels' note in case you're checking it out. Niels' notes, he just says, hey, this h of x derivative is just 1 over gx, and f of t derivative is just small f of t, okay? That's what he says. And then the solution is just replaced here, obviously, right? Like if this is the derivative here, then this integral just becomes h of x is equal to, same argument here, f of t plus a constant. Okay. Again, if you don't like this notation, whatever, just ignore it. Whatever, just ignore it. You once you reach the double integral part, you just solve that. You get a solution for x. You're done. Okay. We're going to do examples in a second. Now, be careful. Whenever you're asked for when you are asked for a general solution of a separable. Whenever we ask for a solution of a separable, he actually wants you to get the constant solutions, okay? Solutions. So in parentheses, if you check my notes, g of 5 is equal to 0, like in the previous page, is asking you for 5, okay? For x of t equals 5, all t's, okay? And then in the second part, he's asking you for what you get after solving that formula. Integral 1 g of x dx is equal to integral f of x dt, or f of t dt. Okay, so that's what he's asking for. And then if he's asking for a particular solution, I'm just, at this point, I think I'm just translating like an English to English kind of version, basically what Neil's phrase is and what you're supposed to give him, okay? But I think it's actually helpful. So when he asks for a particular solution, okay, which means x of a t0 is equal to x0. Remember, like we did in the linear version where I told you find me the constant such that x of 5 is equal to 2021. Sure. Okay. So you can formulate such a problem in this case as well. Okay. And the way you do it is the same exact thing. You're gonna make the constant equal. Okay. But again, you gotta check constant solutions, okay? Constant solutions first. Solutions. For example, remember, let's use the same thing, xt equals to 5. Maybe it works. Maybe this is the solution, okay? For example, because this works for all t. But hopefully it's gonna go. I'll show an example of this as well. Otherwise, do the same thing we did. Otherwise, same as in linear, which is compute the constant, okay? Which is compute the constant. And this is gonna be the last part of theory we're gonna do today. So if there are any questions on the pure theory or all the methods of solving, I'm listening. Otherwise, I'm just gonna take an example, which is gonna be, again, I'll take let's do a more complex, let's say, example. Okay, so any questions up to this point? Or can we just go to the example part? Hopefully it's gonna be clear. Okay. On the examples, let's just take x dot is equal to e to the power of t plus x. Okay. Now, first step is writing it like in my notation, which is e to the power of t multiplied by e to the power of x. Okay. This is my, I think, f. Yeah, I'll write it here. It's x dot is equal to f of t multiplied by g of x. So again, just make it equal. F of t is equal to e to the power of t, and g of x is equal to e to the power of x. Okay? So I made that equal. Now, I'm just going to follow the blueprint. What is it? What is the blueprint? First step, check constant solutions. Okay, what does constant solution mean? It means find x such that g of x is equal to 0. Okay? Now, g of x is e to the power of x for my identification. So this implies that e to the power of x is equal to 0. This is false. There is no such x, right? Like exponent is always strictly positive. There is no such x. So there is no constant solution, okay? That's fine. There is no such x. And I'm done with finding constant solution, solutions. Any questions to what I just did right now? No. Cool. Then now I'm moving to the ugly part, which is solving for g of x not equal to 0. And again, it's separable, so I have x dot is equal to e to the power of t multiplied by e to the power of x. I move this thing on the other side, and I get x dot over ex is equal to e of t. And now I just do an integral, and I get integral from 1 e to the power of x dx is equal to integral of e of t d of t. Okay? Now, maybe if you ask me the following question, hey, I remembered the formula or the semi-formula, whatever, which was integral of 1 g of x dx is equal to integral f of t dt. Can I just replace g of x and f of t? Okay? Like, for example, I don't know, you don't want to remember flipping it on the other side, etc. For some reason, that's perfectly fine, but you just remember this formula. Can you just replace g of x and f of t with what you have here? Yes, doesn't matter. Nobody cares. Okay? As long as you write this integral here, or the corresponding integral in your case, you're fine. Nobody cares how you got to that. It's pretty standard. Okay? Okay, so we got to this point, and now I'm just going to compute these integrals, and I get, this is just integral of e to the minus x dx. It is equal to the integral of e to the power of t is just e to the power of t, e to the power of t plus constant. Let's just call it constant 1. Okay. Now, the antiderivative of e to the minus x is minus e to the minus x plus constant 2, let's say, is equal to e to the power of t plus constant 1. Okay? So now, just rearranging all my terms so it makes sense. E to the minus x, and again, in order to be formal, but feel free to do whatever you want, c minus c2. This thing, you don't need to. You can just write it as a constant, okay? This is just a constant because it's to whatever. So my answer is minus e to the minus x is equal to e to the power of t plus a constant. Is this enough? No. You got to write, you have your final answer should be x of t is equal to dot, dot, dot. Okay, that is how you solve this stuff. That's what you need to show me in the end. So at this point, you're not done, okay? What you have to do is just a little bit more work. What can I say? So you get e to the minus x. I just put a minus everywhere, is equal to minus et minus constant. I take a log and I get minus x is equal to log of minus e to the power of t minus the constant. Okay. So x of t is equal to just minus log of minus e to the power of t minus the constant. Okay, everyone agree with what I did, how I got here? Okay. Now this is my final answer. Let's just say this was part A. Okay. Now part B says find the particular solution such that x of 5 is equal to, I'll make it simple for myself, minus log of 20. Okay. And again, just like in the linear case, all you have to do after you have computed x of t is just replace the t. Okay. Sorry? Okay. I just thought it's a question. Anyway, so all you have to do again is just replace the t. Okay. So my x of 5 is just, and I'm replacing up top, it's minus log of minus e to the power of 5 minus a constant. Okay. And I know that x of 5 has to be equal to minus log of 20. So from here, I can say that minus log of minus e to the 5 minus constant is equal to minus log of 20. So again, all I'm doing is I'm finding the constant. Okay, so I can say that 20 is equal to minus e to the 5 minus a constant. Okay, so the constant is just equal to no, this is harder than I expected. Okay, it's equal to minus e to the power of 5 minus 20. Okay. Now, once you have this, remember, all your answers in differential equations have to be x of t, have to be of this type. Okay. Makes it easier for reading and makes it easier for everything. So just whenever you can, just write the one line. All I'm doing right now is I'm going to replace. The particular solution for that is minus log of minus e to the power of t minus the constant, which I just replaced, minus e to the power of 5 minus 20. And this is enough. Okay. Oh, sorry about that. Yeah. Again, just replaced in the general solution. Okay, and now you're done. You have found a particular solution, and that's it. Yeah.
I don't understand, like, when we solve with like something that's negative, sometimes it's like nothing, so we get like, or it's not definable.
Yeah, that's a fair point. The problem is gonna specify that. That's a fair point. You can only take a log of a positive number, so it's usually gonna be specified that t cannot be negative, or etc. But yeah, I mean it's a fair point. Okay, but any questions on like the method of solving, or how we solved it, or what we did? Otherwise, I'm gonna probably hit you with a new example, which hopefully it's gonna be educated. You know, it's gonna be good as well. So, any questions here? Yeah. 20 comes from here. I just said, hey, find me the particular solution such that x of 5. So when t equals 5, I get log of 20. And then once I have that, I basically have to adapt my constant. You know, I have to find this such that this is true, okay? And I gave just 20 just so it looks better for me, okay? Okay. If there are no other questions, we're gonna go to the next one, which is this even uglier. Okay, this is called, I took it from Moses' notes, but who knows, it's called logistic regression. I don't know it's called this, but yeah, this is what it's called, logistic growth. Okay, is he ever gonna ask you to show logistic growth? No, but maybe it's useful. Anyway, the problem is x dot is equal to Rx 1 minus x over k, okay? Where you know that R and K are greater than 0 constants. Okay, I'll do capital R since my R looks something. Cool. Now, let's see what we have here. Clearly, it's separable, right? It's not the linear part where everything looks nice. It looks ugly. So let's see and identify our g of f of t and g of x. Well, first of all, the main observation is that there is no t there. Okay, it doesn't look like there is a t there. So I can just say f of t is equal to 1. There is no t there. Well, it is what it is.